Welcome to Operating Systems Unit 2, Part 1 on Operating System Design. In the last unit, we talked about the operating system concepts and definitions and the role of an operating system as a management software that needs to allocate resources but also use those resources in order to do the management, which was called overhead. And we went through a bunch of definitions and the components because it's a complex software. We talked about how you can break it up into its different components in order to analyze this software and understand what an operating system does. In this section, we're going to talk about design. If you were to want to develop an operating system, you need to start out by defining the services that it provides and some goals in the development and design of operating systems. So let's start with the services. Operating systems should provide a fundamental service, which is a user interface, a way to interact with the computer system. The next service is program execution. Operating systems should provide the ability for programs to execute on a system, allocate the resources to them, and allow them to perform their tasks. Another service is I/O operations. The operating system should provide a way for devices to be connected, for input to be put into for the processes, and output to come back from the processes and be output onto a screen or into a file or cable or into a buffer or whatever. But this is one of the services operating systems should provide. Another service is a way to manipulate files, a way to create directories, create files, move files, open files, close files, save files, put data into files, read from files. And the next service is communications. Now, one of the roles of an operating system is to, when it allocates resources for a process, one of those resources is memory. So one of the goals of an operating system is to keep processes out of each other's memory space and keep them safe from each other and use system calls to access the memory and allocate the memory and provide communication between the processes. So in that way, the processes would be using message passing in order to communicate. That would mean that the operating system would be involved in the communication between the processes. Now, sometimes the operating system may choose to remove this restriction and allow processes to share memory. So the two basic ways that communication can happen is either by message passing, which the processes communicate by putting the messages into a location and using send and receive primitives, or by removing the restriction that processes cannot access the memory space of another process and allow them to use shared memory. We will talk in more detail about communication later. We're just talking right now about the services that an operating system provides. The next service is error detection. Operating systems should provide a way to detect that an error has happened and find a way to recover from it, log information about it, but there should be a way to deal with errors that occur in a computer system. Other operating system services that ensure efficient operation include allocating the resources, accounting, and protection and security. So resource allocation, we've already talked about how the operating system needs to allocate the resources for the processes, and there are a limited number of resources, and the operating system also needs to use these resources. Accounting means keeping track of which processes did what, keeping track of users, all kinds of information that is logged and kept track of in order to maybe perform updates and things like that. And the next is protection and security. So protection should involves that the access to system resources, controlling all of this access to the resources. And security involves protecting your system from external devices. And so both of these things, without protection and security, the operating system will not run efficiently. And then, because the operating system is a software, there's a separation between what a policy is and what a mechanism is. So anytime that you are developing software or designing software, There are decisions that need to be made. And the first is the policy. The policy is what kind of things would you like to have happen in your system? What kinds of things should your software do? What? Anytime you're saying what it does, what you want to do, those are policies. So once you've made some decisions about some policies, then you can use the mechanism, and the mechanism is the how, or the implementation, or the rules that govern the policy. So we will be talking about policies and mechanisms when we get to some other design decisions later, so I wanted to clarify what those terms mean. But it's not just for operating system, it's for any type of software development. And if you're going to implement an operating system and design an operating system, first you need to start by defining the goals and specifications. And all of these goals of your system, as we discussed in Unit 1, are affected by what type of system you're using, what type of computer system you're using, what type of hardware. Do you have a multiprocessor system, a single processor system, a multi-core system, a clustered system? And what is the goal of your system? Is your system just a basic computer that people are just going to be doing word processing, or people are going to be playing games on it, interactive games on it, or is it a part of a mobile device, or is it a system that's going to be running an airplane? So all of these things will affect your design specification of your system. But in general, the user would like to use your system. It should be convenient, it should be easy to learn, it should be reliable, safe, and fast, which is very obvious. And from the system standpoint, it should be easy to design, easy to implement and maintain. It should be flexible, error-free, reliable. So all of these design goals are very important and very obvious, but as we start to discuss the different ways that operating system services work together and the components get laid out and the different types of systems and different hardwares and things like that, you should keep these design goals in mind. Okay, so that concludes Unit 2, Operating System Design. In the next section, we will continue talking about operating system design. And so thank you very much, and you'll hear from me again soon.